Hello friends, so today we are going to study log. So our chapter 2 will be chapter 2 is logarithm, and in this chapter we are going to study what is log. So log was basically introduced by Napier's, and it is used to simplify the graphs and complex data, and how we say express the log. For example, if I have something like log 2 base 4 is equal to x, so I will say log 2 base 4 is equal to x. Okay, and if you just convert it into an exponential form, it gets converted as 2 is equal to 4 to the power x, right? And so now if you look at it properly, you find that x should be equal to half, right? The power of 4, if it's half, then it becomes 2, correct? So this is the form in which we can interchange or interconvert the log into an exponential form. So whenever we are given a number in an exponential form, we can convert it into log or vice versa, correct? And similarly, if I say, for example, there is a number called 9 to the base 3. So what would be the value? It should be 2, correct? And similarly, like if I have another value called log 27 base 3. So if I solve this one, I get again 3, because 3 to the power 3 is 27. And this is like just the simple form. Similarly, if I say log 2 base 2, then it's 1, right? So this is how we can simply get the values of log. But suppose if I have something like this, log 5 base 2. So now I can't write its simple value as a number, as an integer. I can't solve its value. Why? Because 2 to the power x should be equal to 5. That means the power would be something like 2 point something, right? If it's 2 to the power 2, then it becomes 4. So for becoming 5, it will be 2 point something. I'm not sure what should be the value, but this should be the value, right? And now we can say, like, what are the different conditions for a log to be always true, right? So for a log to be true, there must be some conditions. First of all, if I'm saying this log a base b is equal to m, then a should be always greater than 0, like a should be always positive, and b should be always greater than 0. B should be also positive, b cannot be negative. And the second thing is b cannot be equal to 1. B must be positive and b must not be equal to 1. Why? Because if b becomes 1, then anything power of 1 is always 1, right? So we cannot say, like, if it's 1, then 1 square, 1 cube, whatever power you take on 1, it will always be 1. So the log fails here. That's why it can never be equal to 1. So this is a condition, and these both should be always positive. They cannot be negative. This is just a condition. You can write it down. And then coming on to the properties of log, there are majorly 4 properties. Like the first property is, for example, there is a number called a to the power log x base a. If this is given, then we always get it equal to x, and we can just prove it. So proof. So what I do is, I will prove the left hand side, and I will just take the left hand side. I will say that LHS first. So let's say a to the power log x base a is equal to t. Okay, I'm taking it as a t, and if I take log on both sides now, so log of base a, and this is a, to the power log x base a is equal to log t base a, right? We can do same operation on both sides of the equality. And now if you see, this is like a and this is base is also a. So what you get? This is 1 and the power comes. So it is just like log x base a, which is equal to log t base a. And now if you see, the base are same, so x must be equal to t. So x is equal to t. Therefore it is x. So you can just write down the proof as well. And then the second property. The second property of log is, if there is a number log m base a plus log n base a, then it becomes log mn base a. And this can be again proved if you want to prove it. So suppose I call the first term as x. So log m base a is equal to x, and log n base a is equal to y. Alright, and now if you again solve it, so m becomes equal to a to the power x, and here n becomes equal to a to the power y. Am I correct here? And now if you multiply both the terms, m and n, so you get m dot n equal to a to the power x plus y. Right? And now if you take the log, what do you get? Log mn base a is equal to x plus y. Right? So we get log mn base a. This is log mn base a, and if you write x plus y, you get log m base a plus log n base a. So this is proved. Right? And here I'm proving that LHS again is equal to RHS. Right? So I have started with the left hand side and I have proved it. So similarly, the third property is about the division or the negative sign here. Instead of plus, it's minus here. So property 3 is log m base a minus log n base a is equal to log m divided by n base a. So it gets divided, m divided by n. And again, if you want to prove it, so the first term should be x log m base a, and second term should be y, and same thing, if you just multiply them, you get a to the power x is equal to m, and a to the power y equals n. And now if you just divide them, m divided by n, so you get a to the power x divided by a to the power y, which is equal to a to the power x minus y. Correct? And now if you take the log on both the sides, so log m base n, m divided by n base a is log a to the power x minus y divided by a, which is log m base n, m divided by n base a is x minus y, and x minus y was this one. Correct? So again, it's a simple proof. So this is the third property. You can just pause the video and write it down. So now comes the property number 4, and it is called as base change property. Base change property. Suppose I have something like log a base b. So I can write it as log a base x divided by log b to the base x. And we can see the proof of this one. So I would just assume log a base b as y, correct? If I'm assuming it as y, then a should be equal to b to the power y, correct? This should be the thing. And then if you take base x on both the sides, so log a base x equals log b to the power y base x. And you know that this y can be brought here on the front, right? This power gets multiplied. So log a base x is equal to y log b base x. And now if you solve this one, you get log a base x divided by log b base x is equal to y, which is our proof. So I hope you would have understood this one. So these are the majorly 4 properties of log, and you can just write down. And another thing is, whenever you see something like ln x, so this is always log to the base e and then x. So this is always written in the form of ln, and e is an irrational number which you would have heard about. Alright, thank you for this one. We will continue with the log in next video.